this computer. There we go. Apologies, carry on.
Yeah,
Didn't mean
no worries, that's fine. So I stopped at the question, when you deliver a hardware and you provide a product and the customer has it, the next questions always comes is like, how do we install updates? So what is the way to install updates? And if you don't start thinking about this in the beginning, like when your device is built, when the AOSP is built, and you already have a prototype in the field, there is no way you can update it remotely. At least you will have to go there. So there are many reasons for doing updates. You would like to fix bugs. You don't want to drive there and do it with a USB storage drive or something. You may want to be up to date with all the vulnerabilities and patches. But then a very recent thing and very new thing is also legislation, right? So in Europe, we have for 1 year now that law saying that if you want to bring a product to the market of embedded devices for end users, you have to provide software updates. There is no alternative to that, basically. So people and companies and developers need to start thinking about that as early as possible, and not after the device is actually finished. So in my presentation, I would like to do a short overview of many different questions which are not answered by the AOSP itself, and show you a couple of things which are part of AOSP. Since I don't know the audience, I'm not sure, maybe you guys already know that. So sorry for that. But if not, I will be happy to maybe prepare another topic or presentation, in-depth presentation on a specific topic next time, or ask one of my developers who are actually doing this on a daily basis. So AOSP does provide a lot actually of things to handle updates, and over-the-air updates is also not a new concept, right? We all know that from smartphones, but typically it requires some interaction with the user, and this is not what you would expect to have on the on a professional device somewhere in the field where there is no user in front of them. And companies with 1,000 devices in the field, they obviously don't want to drive there and confirm and install updates. And rebuilding and pre-flashing may work for private use cases like a Raspberry Pi, where you just pull out a Z card and put it back again. But if you have thousands of devices in the field, it doesn't work well. And from a easy perspective, or from a simple process of you build, in the first step you build the image, and then the second step you just install the image. Sounds kind of easy, but let's talk a little bit about what is not included in the AOSP, and what is what do you have to do yourself first. And there are many things. I will dive into detail on the next slide, but just to give a short overview is maybe like device specific config, like what partitions do we have, which of them are updatable, which of them are not updatable, what services are running, which versions, or how to handle versions in general, how do we handle change logs, how do we deliver the package from the moment it's built to some kind of OTA distribution server, and then from there to the device itself. And how do we install that? So do we support recovery, or do we support update engine, or do we support AB, seamless updates, and things like that? So we can, I think, split all of those questions in 3 different categories. And the first one is the build category, like how do we build an update? And the very first thing is, do we understand how to prepare the build environment? And does everyone have a server or a device where they can build Android? I was quite surprised to see that Google recommends having 64 GB of RAM to build the latest Android. I'm started asking myself who is actually having those devices, and I think they have like PCs or servers with 72 cores to build Android in 30 minutes or 40 minutes. That's insane. I would assume that not all of us have that. So that's the first question: where will we be building if we want to do it as a product, right? So we are in commercial product builders, not just some thinkers and do-it-yourself enthusiasts. And the next question will be, how do we automate that? So if we introduce a change, do we want to rebuild it manually and upload it manually? How do we test it? How do we sign the image? How do we monitor the CVEs? You know, yeah, there is a Google with its database of monthly reported closed vulnerabilities, but which of them are already patched in my code base and which of them are not? How do we do dependency management, maybe with other devices? So we, for example, we support up to 6 devices from a single configuration, basically. So which device are we currently building, and which are we uploading, and who will access that, and which configuration is required there? What version do we need? You know, we can use semantic versioning. We can use something else. There are so many questions around that. And how do we change log? Will we present the change log on the device, or will we present the change log on some kind of a web UI where the customer will decide which update to install? And then how do we support Delta updates? So on this slide, I will only ask questions, and on the next slides, I will show you some answers. And there will be a lot of questions, as you will see, because here the journey just starts, right? This is only the part of building Android itself. And then the next part is, okay, we build it. And since we don't want to drive to our device and you know, put a USB flash drive in there and install from that, how do we distribute it? So we need some kind of hosting infrastructure where we can upload the image, and ideally it supports some kind of authentication, so not everybody may upload images to my server from my devices. And ideally it supports signature validation, so we don't so we shorten the process in case of a failure, right? So if something goes wrong, we don't want devices to start updates and then notice that something goes wrong. Ideally it would be done on the server together with the consistency. So I differentiate here between, you know, signature validation, basically checking am I allowed to update that device, and consistency, is this image broken, or maybe some kind of transmission error in there, which I would like to exclude. And if I support multiple devices, so a company with like 5 different flavors, all based on the same type, but with some subtle changes, how do the devices know which image to download and which version is actually meant to be installed on which device? And what I said before, you know, where do you show the changelog? Do you show it on the device? Do you show it on the server, on the administration UI? And the same set of questions we can raise on the device itself. So before we installing something, we need to write some kind of a client. So there is an example client, I think, as part of the AOSP. But we still need to understand how does it integrate. So does it use, I think the current client inside the Google source is using the update engine, but we just got a request 3 days ago from a company who still needs to support Android 6 and create a new build with Android 6 for their devices, where no update engine was available. So do we support the recovery mode? Do we still have a cache partition? You know, all those questions. And then, you know, yeah, some easy tasks like downloading and validation of the versioning and stuff like that. Obviously, that's easy. So let me, in my presentation, let me focus on this last part and maybe dive into it and explain some interesting things in it. So let's assume that we have some kind of a build server, and this build server creates that package, and we know how to build that package, and we upload that to the OTA server. And then we already have Flash devices, so devices where we manage to install our operating system, and we have a client, and this client now needs an update. So the box, the blue box in there, is basically the requirement from the last slide. Sorry? Okay, if you have questions, just jump in and interrupt me. So this is the requirement from the last question, or the last slide, the question we would like to answer. And in the slide itself, like here, you see.
Sí, I'm present.
Hi, there seems to be some.
Yeah, I think it's in
Claro, en realidad, eso no es más que un.
Diane, maybe you can mute yourself. That would be amazing. Thank you very much.
Yep, done.
Okay, so the main question is, like, do we want to enable or disable updates? Or should the device be in a state where updates checks are disabled in general? Maybe some specific time frames, maybe there is a specific schedule you would like to install your updates. And do you want the user involvement or not? So all those questions you need to answer if you want to create a client which will run on all your devices. And then you will obviously ask the server, and it will provide some kind of API. And then this API will need to do multiple things, right? So if you need to authenticate your device to make sure nobody else asks for it, you would need to implement authentication and check the device permissions and check whether this is the correct device asking for the correct image. So if you have 5 different devices, you want to make sure that device A doesn't download updates for device B. And then what I think is the most challenging part is like, how do you decide which version to show? Will you always show the newest update? How do you mark it then if there is a bug in it and you don't want to distribute it anymore? Do you just delete an image, or do you introduce maybe some distribution channels or things like that? So you can do it here. And then when the device receives the version from the server, it needs to understand if this is the version, if the device needs to install it. So if it needs to trigger the actual update process, because maybe that's the older version than on the device, maybe it's the same version than on the device, you don't want to do it all the way. So the client app needs to understand the semantic versioning or any type of versioning you might want to start with. And when you start downloading, well, that's the thing that is the most simple part of it. And when you're done and you downloaded the image, before you start installing it, you need to repeat all the steps you started before, right? So you need to check the consistency, you need to check the signature, you need to check if this is the image for the correct device. Because if you start updating now and it's not, then you're introducing an interruption, right, in the process, and it will take you 5 minutes before the device boots up again with notification that the update failed, and this is not something customers usually like to see on the devices. And then you have to choose the correct flow. So you need to know, does my device support recovery mode? Does my device support AB, seamless updates, and things like that? And after that, you need to do some kind of failover recovery, right? So you need to check, did my update succeed? Because if you're using recovery and you have your only one partition and the device fails for whatever reason, then basically you're done, because you will never be able to update again. And this is actually a very interesting problem we had a long discussion in our team about. So our test process, for example, is that our release process has one step where we, when we want to release one version, we actually release 2 versions and then try to update from the version we actually want to release to the next one. And if that works, then we release it. Because if it doesn't work, then if we would release it, it will be never be able to update again, and then all the devices will be bricked, and our customers will have to drive there and actually, reflash it manually, which would be a catastrophe. I think the biggest client we have has like 15,000 devices in the field. So that would be a major breakdown for everybody. So all of those questions you need to answer. And now I would like to dive even deeper into some implementation details to show you where exactly the developers, so not from the top level perspective, but from the low level perspective, where the developers can actually take influence on that and do things to prevent that or implement or prepare for such cases. So on the next slide, we are basically going through the general consideration of such things. If usually you would say communication should be through TLS or HTTPS, but I saw many cases where customers say, we have our own servers for distribution of the OTA, and we don't want to use that, or we cannot use certificates. So we still want HTTP. So you need to use the clear text traffic in your manifest in order to Android, at least newer versions of Android. I think it started with Android 10 or 11. I'm not sure. Otherwise, they won't even communicate with your servers and won't be able to install any updates from there. For us, for example, we decided to implement several release channels. So we have nightly channel, for example, where our infrastructure builds new images for all our customers and uploads them to the server. And then our customers can decide which of them will be moved to a beta state where they will be tested. And once everybody is happy, then we'll promote them to a stable channel. and then they will be distributed. We decided ourselves to support a semantic versioning, or at least subset of it, because we did try to do it full. We did try to introduce some other versions, but the biggest challenge is, I think, make your customer understand what's going on and which version is what. So what we did, for example, in the versioning, we said that the first number in the OS release version is basically the Android version. So everybody knows what exactly is happening. We have also customers who insist on using letters. We have customers who insist on using some names inside the version. I know that Android has some own build IDs and build versioning, but we don't use that because they're kind of cryptic and it's difficult to explain to people what exactly they mean. So we try to be more readable and understandable for in the images we create. And I think what is really probably the most important part today, due to all the increased cost for hosting and downloads and saving space, is enabling incremental updates, since it saves an enormous amount of space. So the full OTA update, when you build it, can be up to 500, 700 megabyte, depending on the device, while the incremental update for the same device can be 5 megabyte or 6 megabytes. This only contains the binary diff, a binary patch, which is applied on the device, block-based. And I think it's a really nice thing to have. We did not roll it out for all of our supported boards right now, but we are working on that. And if you want to do that, this is what you need to call from the shell. So basically, you call the OTA from target files, and then you provide the previous version you had, the previous device target file you have, and the new one, and then you get an incremental update. This is a very, very important thing. And what is also interesting, in order to downgrade, you actually need to release a new version with that feature being reverted, because due to the rollback protection, Google protects people from using, reusing all kernel exploits or things like that. So there is no way to install an older version when you install the current one right now, unless you compile with a very specific flag, which is the downgrade flag from the OTA target files. You can submit it when you're building an OTA image, and that it would also work. But this, you need to know that. Otherwise, you will just be rebuilding new images all the time. So from the general considerations, I would like to switch to a very, I think, cool feature Google introduced. And I was actually suffering from how it was working before. So I was suffering from, and I didn't like the process of downloading the full image to the storage, to the cache partition, for example, because then the cache partition needs to be as big as the whole OTA, basically, and it's normally empty, so it's not used for anything, and then it's only used to download the full package, which can be 700 megabyte, and wasting up all the space. So what Google said is, we actually don't need that cache partition. What we will do instead, we will introduce AB, or what they call seamless system updates. And probably you heard about that, or a lot of most of you heard about that. But if in case there is someone who doesn't know what that is, basically you duplicate all of the important system partitions, which is system partition, vendor partition, boot, maybe some others, with different suffixes. So you have system A and system B, you have vendor A and boot A and boot B, and then when an update should be installed, you don't have to download or pre-download it. You can stream it directly from the server on another partition. So imagine you have booted from the partition system A, and now you would like to install an update to the system. And what you can do is, or what the system, the update engine does for you, is that it basically downloads the update and installs it immediately to the partition with a different suffix. And
Igor, can I just interrupt you for a second? So you're coming towards the end of your slot, so you have 5 minutes.
Thank you very much for
so yeah, if you can bring it to a conclusion in the next 5 minutes, that'd be great. And then that gives us some time for Q&A following this.
Okay, sure. Yeah. Thank you very much for the note. So you can enable OTA updates, AB updates in the device MK with the definitions you can see here. And basically, when the update is done, you reboot the system, and then the Google follows a specific path where it says checks if the new system slot is bootable, and if yes, it says, "Oh, great, that works." And if not, it fails back to the or falls back to the original slot and boots the system again. So you can be sure that there is always a workable partition, and you can always boot your system regardless of the update state. So I will skip that as well. And I would like to show you one alternative. So that's basically it. I would like to show one thing. Not sure how many of you know that already and heard about the Android Pony Express, which is called Apex. This is a new alternative from Google to basically update components without having the full system update. And this is started with Android 10. And the idea behind it is to create applications which can replace whole system packages. So you can replace system libraries, you can replace holes, you can replace runtime things, and even class libraries at runtime. And there is a list of packages you can see here, which are already Apex compatible. And I find it really cool that you can update the art, like the runtime system, and you can update media codecs just by creating an app, basically. It's designed like an Android app. You create an Apex manifest and the manifest file. And when you install that, the package manager installs an app, and after the reboot or before the reboot, they do some magic in the system by verifying that by updating internal database that an update is being installed. And after the reboot, it creates a loopback device and device mapper block on top of the loopback device, and basically it loads the content of your file on top of what was there before, and it basically is able to dynamically load and unload system changes without creating the full Android update. This is, I think, also a topic for a different, for the second meetup, where we can dive in detail, and I will also show you some code, but there's a lot of documentation and a lot of sample implementations here in this link. And as a maybe last slide, just to give you maybe a better idea of what exactly we are doing and at Emteria, and we're doing exactly that. So we provide customers with possibility to provide customizations and requirements for their functionality, and we in our cloud we build the system and we put the customization on top of it and provide them basically with a custom CI/CD pipelines for the whole OS with the customizations on top, so they can deploy different versions of their images to their devices. And that's it. Thank you very much for your attention.
Okay, fantastic. That was really, really good. Does anybody have any questions for Igor about OTA and Emteria in general? If so, now is the time. So I've got a couple of questions. So first of all, how much of what you describe here is part of AOSP, and how much of this is your own tooling that you've developed for Emteria? Sounds like it's a combination of the two.
It's a combination, yes. So what AOSP does is it provides you tools to do things, but it's still your responsibility to implement all of that. So it's your responsibility as a developer to decide what exactly you would like to have based on the requirements for the product. So if you're building a product with a limited storage space and you cannot afford having, let's say, a B partition, so you cannot duplicate all of those partitions, then obviously you have to go with recovery. And this decision has to be made by the developer. What Emteria does is we support people in their way, and we don't implement AOSP extensions in the OTA part, but what we do is we implement our client. So we do have a client which supports all of that depending on the requirements we have, but we don't develop new ways of distributing things.
Okay, cool. And the other thing, kind of leading on from that a little bit, so this is a hot topic in the automotive industry. I'm just wondering if you've had any contacts with automotive vendors, tier ones or whatever? Because it seems to me this would be very, very useful in that kind of area.
This is a very difficult market where it's even more difficult to work as a startup, I think, or a small company at least. We had quite a big project with a big German automotive last year, where we were more of consultants, not part of the development team, so to say. And I know that many companies are very protective about what they're doing. So all of them want to own the things they do. And then it leads basically to rebuilding and reinventing the wheel and doing all the same, over and over again, right?
Yeah, I can imagine.
And what's also interesting, we had an interesting project with Intel, where we talked to their department for automotive. Intel is also a little bit, so they don't share everything they know with us, but what they said is that in the automotive space, they would like to differentiate between updating some kind of non-critical systems with Android and updating the actual MCUs. So that's really fragmented market, and it's difficult to supply one product or one tool which would cover all of that. So I'm very eager to see how the future will develop, because with the rising computational power of the devices we see today, you can actually do some kind of workload consolidation and do all the things in the same place, and then having one big operating system would actually be a solution and not a problem. So I'm looking forward to see how that will develop.
Yeah, that's a good point. Yeah, so there's more to a vehicle than just the head unit. There's also all the various ECUs and whatever. That's a good point. Okay, anybody else out there? You've all gone very quiet.
Okay, guys, thank you very much.
Okay, well, thank you very much, Igor. That was really, really great stuff. Appreciate it very much, and hope to see you along at future meetups.
Oh, I will be here. Thank you very much.
Great, and maybe see you at an on-site conference sometime.
Oh, that would be great. I miss those actually, due to COVID restrictions. I haven't been to one for quite a while now.
Yeah, absolutely. So Dublin is going to be the next big one for me, at least. And then I'm hoping that we can do FOSDEM next year. Hoping to see FOSDEM come back online. But we'll see. Whatever happens is whatever happens.
Great. Guys, thank you very much, and have a great evening.
Okay. Well, thank you very much as well. Okay, what to do now? So the section in the schedule says Q&A and networking. But I I can't do everything, so I don't know. Let's just open up the floor for a moment or two. Is there anything anybody wants to talk about? Interesting things they've done recently with Android, or particular things that they're stuck on, or whatever. Tell me, guys and ladies, what is it that's keeping you awake at night? Or is it just the hot weather?
Or maybe topics you would like to hear next time, or see a deeper dive into something specific.
Yeah, indeed, that would